Let's talk about Venn diagrams and tables, which are both powerful tools in determining conditional probabilities. So, Venn diagrams are used to represent the actual counts or percentages for different outcomes of an event. In this case, I have 452 students who are in geometry, plus another 23 that are in geometry and algebra 2. I have 154 that are just in algebra 2 and 47 that are not in either one of those math courses. They're probably in pre-cal or calculus or even AP stats. All right, so the question first, we're going to use the Venn diagram to determine the number of sophomores in geometry and algebra 2 at the same time. The way I know who these are is what parts of the circle contain both the geometry circle and the algebra 2 circle. Well, it's that center part right there, the 23. Now, the total number of sophomores in geometry, I actually have to combine both these two. It's 452 plus 23, which is 47. The number in algebra 2 is 154 plus 23, which is 177. Now, this one, the number of sophomores in geometry or algebra 2. There are a couple ways to do it. For me, the easiest way is just to add up anything that falls in a geometry or algebra 2 circle. Just make sure not to double count it. The other way to do it is you can actually add up the total geometry plus the total algebra 2 and subtract the overlap. So we get 629. Finally, the total number of sophomores are these 629 students plus those 47, or 676. And we'll need this for some of the probability problems we'll do next. In this example, we want to calculate the probability that a sophomore is in geometry. So we know that there are this many sophomores in geometry out of a total of 676. I have to include everyone, and I get 0.073. Now, the problem changes if I say a sophomore is in geometry given that they are in algebra 2. So that limits my circle here. So my world gets limited to just this. I don't care about anything else. So it's going to be the 23, all right, over the 177. Now another way to, so I'm doing right there. So I have 23 over 177, which is 0.103. Now the probability that a sophomore is in algebra 2, that would be there are 23 plus 154 students out of 676, so I get 0.262. That they're in algebra 2, given that they're in geometry, so that's this circle right here is my given. I ignore everything outside of it. And so I will have 23 students out of the 475. Okay. Now, a sophomore is in geometry and algebra 2. That's just this group right here. And that would be 23 out of 676. Remember, this symbol right here means and. Now, a sophomore is in geometry or algebra 2. That means I'm going to combine all of these, all right? Or I can just do the totals and subtract the overlap, which is a 23 out of 676. And I get 0.930. Again, this symbol is the or. The upside down symbol is the and or the intersection. Now, sometimes you'll have problems without Venn diagrams. Miss Wu teaches geometry and algebra 2. The probability that a student will get Miss Wu for geometry is 0.18. The probability that a student will have Miss Wu for geometry and for algebra 2 is 0.03. What is the probability to the hundredths that a student will have Miss Wu for algebra 2 given they had her for geometry? A lot of times when you see that word if, that can be said as given. So the probability of geometry is 0.18. For geometry and algebra 2 is 0.03. I gave you this formula. Probability of algebra 2 given geometry is geometry and algebra 2 over just geometry. So I kind of memorize these. Both of these are on top and they're an and then the second one is on bottom. So I can actually just make a fraction out of these two decimals, and my answer is 0.167. How does that make sense? Well, if I did a Venn diagram and I have 0.03 here and 0.15 there, there's the number of people who are in geometry and algebra 2, and then the total that I'm interested in is just that one. Okay. Tables are also really helpful for solving probability problems, especially conditional. So we're going to determine the probability that we looked at some Cedar Ridge High School graduates who had completed the Algebra 2 requirement for graduation. And here are the results. And we're going to look at the following probabilities. Let's say they took, what's the probability these graduates took pre-AP geometry? Well, we know, first of all, there are 435 geometry students, right? 221 pre-AP geometry, right? And 476 Algebra 2 students plus 480 pre-AP Algebra 2 students, giving us a total of 656. That's my total of all the graduates. Well, the probability they're in pre-AP geometry, I don't care which algebra they took, so I can actually look over here. By the way, this is something called the marginal distribution when you have it on the ends like that. So 221 out of 656 would be 0.337. What's the probability they took pre-AP Algebra 2? Well, I have 180 total there out of 656, or 0.274. Now, let's take a look at the probability they took pre-AP Geometry and pre-AP Algebra 2. Well, only these students right here took both, and that's out of 656, or 23.9%. Now, does the product of pre-AP Geometry times pre-AP Algebra 2 work? Why or why not? So when I multiply these, I don't actually get the same probability. That's because the events are dependent. Pre-AP students tend to take all pre-AP math, and so they tend to be in the same grouping. So when things are dependent, you can't just multiply the probability of, oh, if they're in pre-AP Algebra 2 and pre-AP Geometry, I'll just multiply those probabilities. Doesn't quite work so well. Now, the probability they took pre-AP Geometry or pre-AP Algebra 2. So there's pre-AP Geometry, there's pre-AP Algebra 2. I can add both of those and subtract the overlap, and I get that probability. There is, why doesn't the sum of the probabilities work? Well, here I'm getting 0.611 if I add the probabilities from before when we calculated them. And the reason is we're double counting that 157. So it actually gives us a higher answer. And you can see that if you're in pre-AP Geometry, you're much more likely to be in pre-AP Algebra 2. Okay. So the 157 students who took both are double counted when we just sum the two probabilities. Now we're going to look at pre-AP Algebra 2 given they took pre-AP Geometry. So this is remember, now we're doing a given probability. And that means my world is limited to just this row. I don't care about the row above it, and I don't care about the row below it. So given that they took pre-AP Geometry, so I'm just looking at the pre-AP Geometry row, there are 157 students out of 221, or 71%. So if you took pre-AP Geometry, there's a 71% probability you're taking pre-AP Algebra 2. What's the probability they took pre-AP Geometry given they took pre-AP Algebra 2? That's the column now. So that's my world. I don't care about anything outside of it. There's my 157, so it's still the same number, but now what goes underneath it is 180 because I'm looking at the total of Algebra 2, pre-AP Algebra 2 students.